Need to connect to an MCP server with OAuth, but don't want to implement provider-specific flows in your client? We'll show how Auth equals OAuth lets the FastMCP client offload the entire OAuth 2.1 process to the server, assuming the server has the required provider configured, like Auth0 provider with config URL, cliented, and other settings. You'll see how this three-line pattern triggers a browser-based OAuth flow on first connection, handles PKCE security, and manages token refreshes automatically, while keeping all provider-specific logic on the server side. From FastMCP import client. Hash uses default OAuth settings. Async with client. https://fastmcp cloud/mcp auth equals OAuth as client. Await client ping. This demonstrates server-managed OAuth delegation, where the FastMCP client uses a single configuration flag to trigger a complete OAuth 2 flow handled by the server's Auth0 provider implementation. The pattern separates client concerns from authentication complexity by requiring explicit server-side provider configuration, including config URL, cliented, and client secret, while the client only needs to specify auth equals OAuth to initiate the flow. The distinctive aspect is how it moves all provider-specific logic to the server, where supported OAuth providers like Auth0 or Okta must be pre-configured with their respective adapter implementations. The approach works through a coordinated client-server handshake, where the client's auth equals OAuth parameter signals the server to manage the entire OAuth flow. On first connection, the server initiates browser-based authorization using PKCE, handles the authorization code exchange, manages token storage and refresh cycles, and maintains the OAuth session, all while the client remains unaware of the specific provider or security protocols in use. This delegation means your client code stays identical across different OAuth providers, but only for providers that have corresponding FastMCP Auth provider implementations configured on the server. The server must be running with HTTP transport to support the required browser redirects and callback handling. This pattern matters because it dramatically simplifies client implementation while maintaining security best practices, though it requires significant server-side configuration. The trade-off is that servers must implement provider-specific adapters and manage all OAuth parameters, including production requirements like JWT signing keys and persistent client storage. The approach is ideal for systems where multiple clients need standardized access to OAuth-protected MCP servers, as it centralizes all authentication complexity on the server while keeping client connections simple and consistent. The first client connection will always trigger the browser-based OAuth flow, with subsequent connections using cached tokens until they expire. Let's break it down line by line. From FastMCP import client. Imports the client class from FastMCP, which requires server-side OAuth provider configuration, typically Auth0 provider with config URL, cliented, and other provider-specific settings. The auth equals OAuth parameter triggers a browser-based OAuth 2 flow on first connection, delegating all token management, PKCE, refreshes, validation to the server while keeping client code provider-agnostic. This pattern works with any OAuth provider supported by FastMCP's Auth provider system, not universally, but eliminates client-side token handling. The server must run with HTTP transport enabled, and production use requires additional configuration like JWT signing key for secure token persistence. Hash uses default OAuth settings. Async with client. https://fastmcp cloud/mcp auth equals OAuth as client. This creates an OAuth 2 connection using FastMCP's server-managed provider flow, requiring an Auth0 provider or equivalent OIDC provider implementation configured server-side with config URL, cliented, and signing keys. The auth equals OAuth parameter triggers a browser-based OAuth flow on first connection, with all token handling, including PKCE, refreshes, and JWT validation, delegated to the server. The context manager ensures proper session cleanup, while the server's provider implementation, Auth0, Okta, etc., handles provider-specific details transparently. For production use, the server must also configure token persistence via JWT signing key and storage backends. Await client ping. Verifies server connectivity while delegating OAuth 2 OIDC flows to the server, which must have an Auth0 provider or equivalent configured with provider-specific settings like config URL and cliented. The first connection triggers a browser-based OAuth flow, with the server handling PKCE, token refreshes, and storage, keeping client code simple but requiring explicit server-side provider configuration. This pattern works with any OAuth provider that has a corresponding FastMCP Auth provider implementation, assuming HTTP transport and proper JWT signing keys are configured. OAuth client abstraction. The auth equals OAuth parameter creates a clean separation where clients handle connection lifecycle while servers manage provider-specific OAuth flows. But this simplicity requires explicit server-side configuration of providers like Auth0 with their respective credentials and endpoints. The first client connection triggers a browser-based OAuth flow that only succeeds when the server is running with HTTP transport and has a properly configured Auth0 provider with config URL, cliented, client secret, and audience parameters. Production deployments need additional token persistence configuration, including JWT signing key and client storage, to survive server restarts.
The client that speaks universally does so because the server first learned every dialect